All right, I figured I'd make this video not only help the student that is doing this, but also help anyone else that's in this situation. Just to give you an idea, I actually love engineering format and helping students making sure they document things correctly and do engineering format correctly. Okay. Um, I have seen it work in industry. I have seen not only the organization, the format, but you will get material a lot faster doing it the way that I ask. Okay. So I love providing feedback, and I figured videos are the best way. So just kind of quickly off the bat, never put the page numbers on the paper, they go in the heading here. Okay. So you can erase that. And that's why we use pencil. And then just make sure when you're done with your homework, you put the full page numbers, okay, on the bottom. So this would be page 1 out of 10. All right, awesome. Uh, Problem statement's fine. The free body diagram or sketch, this is great. It could be a little bit bigger, but I can read that. That's fine. Um, you got your dotted line for control volume. You got your external forces. You got your pressure force right here. I would maybe, I mean, you labeled it B and A. You could label it like V, VB, and VA if you wanted to. Okay, but I'm not too picky on that because you labeled it A and B. All right. All right. The only thing that I noticed is you didn't have a find. So just make sure you put find and what you're looking for. Um, you can do assumptions as well. I didn't put that here. So this would be steady state and incompressible. Okay. So steady state means conservation of mass. What comes in must come out. And incompressible is the density of the liquid is going to be the same. It's not going to change. Okay, now let's scroll down here to your solution. A few things. Let's start on the left. So you see here you have a solution and then you just started writing this box equation that I have. Don't do that, okay? You need a heading. So I put linear momentum and underline it and then put that, okay? And then you noticed where this is good. You went down here, you went down to here, and then all of a sudden you jumped and you have this fx equation, which you could label equation 1, but you need a heading to say, okay, I'm now finding this pressure force. Now I'm finding the velocity. Now I'm finding the mass flow rate. And now I'm finding fx, or now finally, or you could put now, or you can put from equation 1. Maybe that would be better. From equation number 1, underline. Okay. Now, one thing I did notice is you don't have any units in any of your calculations. You have to have the units in there. Because how do you know this is slugs per second? I don't know. How do you know this is pounds? Do you have a Newton in here somewhere that you messed up? So make sure you put the units in there. Okay. So over here on the right, it's very similar. You didn't have a heading. The other thing you want to mention is your direction for forces. Which direction? Up is positive for y, to the right is positive for x. This is good, okay? Very important that you have this negative here, right? Because it's going in, it's your direction, right? This is the key to make sure that that negative is correct, all right? Again, heading, find VA. Now, there's no negative here because it's you're finding flow rate, or it's really flow rate. So should be no negative here. Okay. Again, need a heading for mass flow rate. Um, and I'm trying to think. That doesn't look like the right equation. Double check this. Like, where did this come from? I'll talk about that in a second. And then what you can do is you can call this equation number 2. And then you can say from equation 2, underline, and calculate it. Okay. Now, don't calculate the calculation and the number. Should only box the number. Okay. So make sure you do that. Now, one thing that I did see that you're missing is the conservation of mass. So somewhere you could put it as a side note. Um, you kind of did it when you're finding the flow rates. Oops, let me back this up. Undo. Um, but somewhere in the headings, you want to put conservation of mass, and you want to state that summation of m dot in equals the summation of m dot out, and it would be m dot b equals m dot a, and then just call that m dot. And then you could put rho AV for your equation. Okay, so or because you're using Q, you can do Q dot or just Q in equals Q out. Okay, I don't use Q. I use V dot in equals the summation of V dot out. Then it would be AB VB equals AA VA, right? Okay. So you have the equation. Where is it? Right here. See that? That is what V dot is. Okay. So Q V dot is AV. Um, I would start not with your equation there. I would simply say a V dot equals a V and then rearrange because it's going to help you. Okay, which would be what V over A, like you have. Okay, so uh, the reason I'm doing conservation of mass is because one of the homework problems there are one inlet and two outlets, and you have to make sure you put this equation in here with a heading, and that's the only way you're going to find the right velocity. Okay, so um, again, I am very picky, but I want to make sure you're doing this right. Okay. Um, so the student that's doing this right now, you don't have to redo this one. Work on your next one. Okay. You kind of see what I'm asking for. All right. Okay. I hope that helps. And I hope this helps for everyone else too. Thanks.